Okay, notes 3, Venn diagrams, unions, and intersections. Venn diagrams, it says we can represent events with a Venn diagram, which is a display of potential probabilities. The box around the Venn diagram represents the total sample space, where the probability of the entire sample is equal to 1. Okay. The circles themselves represents the probability of each event. Okay, so for example, event A, event B, the overlap between event A and event B, and then the outside is all other probabilities. Okay, so this entire space of the box, including the area of the circles, is always going to be equal to 1. Okay, now let's talk about the symbols union and intersection. So union means or. You should be familiar with the union symbol when you talked about domain and range in Algebra 2. When you said, okay, the domain is negative infinity to 9, union 9 to infinity, which means it was everything except the number 9. But it meant that you take both of those intervals and combine them together. So it's the probability that either or occurs. So the probability that either occur, and the symbol is a U. Intersection is the probability that they both occur together. And the symbol looks like a N, or an upside down union. So if we said the probability of A union B, this is the probability of A or B happening. So this is what the shading would look like. Okay. If we said probability of A intersection B, this is the probability of A and B happening together. So again, what that shaded region would be. Okay. If we had the probability of A complement, remember A complement is 1 minus the probability of A. This is the probability of A not happening, or we say the complement of A. So the probability of A not happening is everything else. So that is not only B, but the sample space, or that box around the entire thing. So that shading represents the probability of A complement. And then the probability of A complement intersects B complement is the probability of A and B not happening together. So we're just talking about the sample space as a whole. So if like the probability of A and B not happening together is 0.8, since the sample space as a whole is 1, then we know that probability would be 0.2. We would do 1 minus 0.8. So again, this is what the shading would look like. So let's look at an example. It says shade the probabilities for the following notation. So the first one says the probability of A intersection B complement. So this is the probability of A. Okay, so I know it's the probability of A. Okay, and so let's see, to make this a little easier, what I'm going to do is I'm going to do each section so you can see what each section is. Okay, probability of A. Intersection, the probability of B not happening. Okay, well, B not happening, okay, would mean that B is not included at all. Okay, well, notice when I shaded A, I still have a part of B in there. So technically, the probability of A intersection B complement is only going to be the probability of A without that overlap of B. Next, the probability of A complement. Okay, remember A complement is the probability that A does not happen. So that's everything outside of A, or the probability that B happens. Okay, so here's the probability that A doesn't happen. Okay, that's all of this right here. A doesn't happen. That means we highlight everything but A. Okay, but then it says, or B can happen. Well, if B can happen, then that means we can include that little section here, because where they overlap A and B is including B itself. So that would be the shaded for A complement union B. Okay. Then we have the probability of A complement or B complement. So A is not happening and B is not happening. Okay, but it says or B is not happening. So if A is not happening, that means B can happen. But if B is not happening, that means A can happen. But we don't want them happening individually. Okay, which means that this would be everything except the intersection. Okay, everything but the intersection. Because remember that the probability of A intersection B is going to be just that middle part. So the probability of A not happening or B not happening would be all the areas except where A and B happen together. Okay, example 2 says in your stats class, you're interested in exploring the taste preference of your classmates. You have 2 tastes, sweet and salty. 25 students were asked if they preferred both, only sweet or only salty, or neither. The following two-way table shows the data. It says let A represent sweet, B represent salty, and draw a Venn diagram in the space above and find and interpret the following probabilities. Okay, so looking at the table, A is sweet. So I look at my table. Well, who liked sweet? Okay, yes to sweet was 17. Okay, so yes to sweet was 17. Okay, here's 17. Let's see. No to sweet. That means they like salty. No to sweet was 8. Okay. Let's see. No to sweet. Okay. Sorry, 1 second. I'm looking through this real quick. A is sweet. Okay. Let me rephrase this a little bit. Okay. So if A is sweet, that means they are saying yes to sweet but no to salty. Well, that would be 11. Okay. And if B is salty, that means no sweet. Okay, so that means they're saying yes to salty but no to sweet. So that's 7. Okay. If they like both, so yes to sweet and yes to salty, so yes to sweet and yes to salty, that would be 6. That's where they overlap. Okay. And then the other one says no to salty and no to sweet. That means they don't like anything. Okay, that's going to go in the sample space out in the side. So if we were to add these all together, we should get our total of 25, which we do. Okay, so now using that Venn diagram, it says, what is the probability of A intersection B? Okay, A intersection B is where they overlap, so that's 6 out of 25, which is 0.24. So it says the probability a student in class likes both salty and sweet is about 24%. Part B, would be the probability of sweet or salty. Okay, so sweet or salty means this is the 11 out of 25, that's the sweet, plus 7 out of 25, that's the salty, plus 6 out of 25, which is sweet or salty, which is 24 out of 25, which is 0.96. So you would interpret that as the probability a student in class likes either sweet or salty foods would be 96%. Part C says the probability of A intersection B complement. So what that means is that probability of A is, okay, they like sweet. Okay. Intersection means and B doesn't happen. So if B doesn't happen, that means no to salty. Okay, so they like sweet and no salty, which means they like sweet, only sweet. So that would be 11 out of 25, which is 0.44. So it's the probability that students in class like sweet but not salty would be 44%. Okay, then the next one would be the probability of A complement. So that's no sweet or salty. Okay, not no sweet and no salty. It's they don't like sweet at all. Or they like salty. Okay, so that would be the probability that they like salty, so 7 out of 25, the probability they like neither, 1 out of 25, and the probability that they like either, 6 out of 25. Okay, this would be 0.56, so we would say that the probability a student in class likes no sweet foods or likes salty foods is about 56%. E is the probability of A union B complement. So this is sweet or no salty. Okay, so this would be the probability of sweet, so 11 over 25, plus sweet or salty, meaning they can like either, so that's 6 out of 25, or they could like neither, 1 out of 25, and that would be 0.72. So the interpretation would be the probability that a student in class likes sweet foods or does not like salty foods is about 72%. And then lastly, we have the probability of A complement intersection with B complement, so it's not sweet, not salty, and this is and. Okay, so that means they don't like sweet and they don't like salty. Well, that was only one person, so 1 out of 25, which is 0.04, and that interpretation would be the probability a student does not like sweet foods and does not like salty foods is about 4%.